In this video, I'm going to use a fun and simple way to explain why language models sometimes produce what are known as hallucinations, what's called hallucination in English. To get straight to the point, hallucination isn't actually a bug in the system. It's a feature of how these models work. Just now, I asked GPT-5 on Poe to give a brief introduction about OMP Arshek's background. It got a bit right. It said Arshek is a YouTuber who introduces car culture. But this part is actually wrong. I've never introduced used cars before, so it's the same kind of thing happening here. Right? So I tried asking again just to clarify. This time it gave a different explanation. Apparently, OMP stands for One Man Production, which I just found out myself. It said it's about current affairs commentary, funny short videos, and gaming live streams. Earlier, you saw how confidently it gave the wrong answer. That's exactly what we call a hallucination. To understand this, you actually need to know the nature of large language models. They're basically predicting the next word. It's a bit like when you use Google, for example. When you type how to and then below, you'll see different suggestions pop up, like forget someone or how to forgive yourself. It predicts the words that come after based on the first part you typed. So when you enter your prompt in Poe or ChatGPT, it's actually predicting the next word based on your prompt. For example, if you type I like, it will assign probabilities, like there's a 38% chance the next word is you, 25% for being, 12% for the, or maybe a. Or maybe the word sell appears. When you usually see ChatGPT responding to you, the words come out one by one, right? Actually, that's not a deliberately designed effect. It's really outputting word by word. And after each word is output, it predicts again what the most likely next word will be. For example, if it chooses a word based on probability, that doesn't mean it's 100% certain, right? There's still a 25% chance it might pick being, for instance. So if it goes down the being path, then the next word will follow from there. For example, register might have a 15% chance, like in I like being creative, and another 12% chance for I like being alive. If it goes with the earlier path of I like you, then there's a 55% chance that a full stop will appear. A full stop is also considered a token. You might wonder how these probabilities are determined. They come from learning from a massive amount of internet data, like the 4 books and 5 classics. So it knows which word is most likely to appear next. And when it outputs, it uses these probabilities. To some extent, this can be controlled, and this setting is called temperature. If you set the temperature very low, it will most likely choose the path with the highest probability. On the other hand, if you set the temperature higher, for example to 2, then those words that originally had a lower probability will become more likely to appear. In other words, low probability becomes high probability. For example, something that was originally at 25% might become 29%, and something at 12% might become 20%. That's how it works. A probability of 1% might become 5% and so on. So by adjusting the temperature, you can control the randomness. Normally, when you use ChatGPT or Poe, the default setting is usually 1. Now, what you see on the screen is the OpenAI developer platform, where you can adjust the temperature. By tweaking this setting, you'll get a clearer understanding of the characteristics of the language model's output. Here, let me check. Here. I've selected the GPT 4.1 model. You can see that the default temperature is 1, and I'll set it to I've set the temperature to 0 on the right side here. Similarly, I've selected the 4.1 nano model, and likewise, I've reduced the temperature to 0. Next, I'm going to ask both models the same question and see how their outputs compare. Here, I ask them to simply explain what quantum mechanics is. Now, you can see that the results are exactly the same. The reason is that I've set the temperature to 0 for both models, which means that for every word they output, they are always choosing the most likely word. This particular setting removes randomness, so both models will always produce identical responses to the same prompt. It always picks the most likely option, which means the answer it provides becomes a deterministic one with no randomness or variation. Next, I'm going to set the model's temperature to 2 and then ask it the exact same question as before. Simply explain what quantum mechanics is in a way that's easy to understand. Here you'll notice that its response is very strange, almost slanted or skewed, and not only does it start talking nonsense, but it even produces some very different, unusual and unexpected kinds of text. Here, you can clearly see that when I adjust, after adjusting the temperature parameter, the randomness involved in predicting the next word increases quite a lot, making its output seem even more illogical and bizarre than before. Through this demonstration, I want to clearly show you the true nature of a language model. What is its fundamental essence? It's that, based on probability, it continuously predicts the most likely next word to appear in a given context. So here, I've actually answered 2 common questions. The first is, why do I get slightly different answers every time I ask it the same question? Now let's take a closer look at this. Now you know it's actually because, to some extent, it follows different paths based on probability. The second common question is, why does it hallucinate? Actually, that's just its nature, essentially. When it follows a certain path and outputs text that isn't the answer you want, you feel like it's hallucinating. But in reality, it's just doing what it's supposed to do, constantly predicting the next most likely word. So you might ask, should we set the temperature of all language models to 0 so that every single time it outputs, it always picks the most likely option? Actually, the biggest difference between a language model and a traditional calculator is that a calculator is deterministic. The answer you get is always consistently the same. But what truly sets language models apart from traditional machines is that they possess creativity. They can dream. You own a machine that can dream. The only issue is, when a language model is supposed to be an assistant, how can we reduce its chances of giving wrong answers? One way to do this is called RAG. Simply put, it means providing it with helpful tools, like letting it access the internet to reference the latest online information when answering, instead of relying solely on the knowledge it was trained on before. For example, just now I used GPT-5 in Poe and asked it to introduce the background of OMPRSHEK. But since the GPT-5 in Poe doesn't have any tools, meaning it cannot access external sources, it can only answer based on its pre-existing training data, which may not always be up to date or complete. Doesn't have internet resources and tools, so it can only use the knowledge in its own brain, constantly and repeatedly predicting the most likely next word. As a result, the answer it gives is wrong. Now, if I ask the same question on ChatGPT, and this time I provide it with a tool called web search, then send the question, you'll see that its answer is correct to occur. It even pulled up my photo. I wrote a book called Marketing is King, and my real name is Shek Kawai. It knows that too, as well as my background. This background is found from the website. So here you can see that by providing additional tools, like letting it search for information online or look up data in your company's database before answering, you can further reduce the chances of it hallucinating. Of course, sometimes the information it finds online can also be wrong. For example, when Wikipedia first launched, people trusted it too much, but actually the information on Wikipedia can also be incorrect. So, even though hallucinations are not completely solved, but by providing tools that let it cite sources when answering, you can greatly reduce the chances of it making mistakes. Here, let me quote an article by Angel Kapathy, one of the co-founders of OpenAI, to respond to this question. He mentioned that hallucination has always been something LLMs do. They are essentially dream machines. He also shared a very interesting perspective. He compared LLMs to search engines. Search engines have no creativity. They hallucinate 0%. In contrast, language models are, in essence, dreaming at 100%. They are constantly hallucinating, and that's their very nature, their fundamental characteristic. When we use language models as assistants, we can leverage RAG, which means providing them with some extra additional information. This way, a dream machine can have a good dream and come up with an answer that the user truly wants. So, according to his perspective, hallucination isn't a flaw. It's actually the greatest feature of language models. For AI assistants, this is a problem that we need to solve. Under this post, Elon Musk also left a comment saying that life itself is just a dream. I hope today's content has helped you better understand the true nature of language models. Coming up in September, we will have 2 workshops. Among them, the AI Upgrade and Transformation Workshop on September 20th is suitable for all interested participants. In this class, you will learn about real-world applications at work, and secondly, you will gain enough capability to communicate with an IT company about how to help them develop AI application courses. The early bird offer will end next week, so if you're interested, you can click the link below the video to learn more about our courses. See you next time.